Hello everyone. I hope you are having a wonderful time at the safety of your homes. And welcome to AESP314 Energy, Power, and Propulsion. I see most of you guys, based on the roster that I've received from the university, I see most of you guys are returning students, so know me pretty much, pretty well. And we have some new faces, which hopefully we're gonna meet each other next week on Monday. So what we're gonna do today for the first class, for the Friday, is essentially I'm gonna go over the syllabus. I'm gonna go over the class rules. I'm gonna go over the special circumstances we are in, and we will talk about those things. And then in another lecture, which will be posted separately, I will talk about chapter 1 of your textbook. So keep in mind that you are not required to buy the textbook. It is always better to have the textbook, of course, but you are not required to buy it. Hopefully what we do here, what I say, will cover whatever you need. And if you decided not to buy the textbook and felt like that there are some things in the homework and the exam which I haven't covered in the class, you are always welcome to talk to me, send me an email, ask a question, and so on and so forth. So today we will have a little bit of introduction. I will introduce myself. Unfortunately, you won't have the chance to introduce yourselves, but we'll get to that on Monday, which is going to be the upcoming Monday in 3 days. And then we will move on to syllabus. I will go over the syllabus. I will explain whatever you need to do, your grading, your assessment, and everything. We will talk a little bit about my expectations from you, and I will ask about your expectations from me on Monday. And the historical perspective of the flight and the introduction to propulsion will be discussed in a separate lecture. Well, both of them will count as the first lecture, essentially. The reason I want to separate them is because I want you to have a separate recording of the class rules and this explanation of the syllabus, which you can always go back to and check if you had any questions, and then the sciencey stuff will start from another lecture. And today we will also talk about the roadmap and the course topics in this first lecture. Okay. There's one thing that I want you to keep in mind is that I will prepare PowerPoint. I have prepared PowerPoints for all of the lectures, all of the chapters, but the PowerPoints are not based on lecture, are based on chapter. So we will have a PowerPoint on chapter 1, which is going to be your introduction and syllabus, essentially, your introduction chapter and syllabus. We will have a PowerPoint in chapter 1, and so on and so forth. Okay, who am I? I got my bachelor's from University of Tehran, which is located in Iran, in 2012. You can see this is an evolutionary human. And I got a master's from University of South Carolina in 2014, and I received my PhD from University of South Carolina again in mechanical engineering in 2018. And from then I've been hired as an instructor for the aerospace program from 2018. Hopefully I will be in this position for a long time. Okay. So that's a little bit of introduction of me. Usually this introduction takes a little bit longer because we get to discuss and talk about this in class. But let's go to syllabus. Let me bring out the syllabus from your Blackboard. it is not a bad idea to talk about Blackboard a little bit as well. So what we are going to do in this class is that we are going to talk to you guys through Blackboard. Whatever menu you see here is going to change a little bit, but you're going to have the home page, you're going to have the course contents, assignments, and I will keep the discussions in group just in case you want to talk to each other, or we may want to have a class discussion outside of class, which we can do here. And we have to keep the Blackboard Collaborate Ultra, but I usually don't use the Blackboard Collaborate Ultra. I usually, if we are going to have the online section of the class, which we always will have, so I will always post a recording. It doesn't matter if we do the face-to-face classes or not. Okay. At this point, it may change, but at this point, I don't use the Blackboard Collaborate Ultra at all. We are not going to have any live online sessions. It is either face-to-face or pre-recorded. And but university policy may change. They may ask me to have live recording, but I will let you know. I will keep you in the loop. And then another tab you will see later on here is going to be your grades tab. You are not going to see these tools. Are you actually? This is not your view. This is what I see. So, okay, let me change the view. Yeah, this is what you guys see. I'm sorry. And I will talk to you through announcements. Whatever I say in class, you should receive an announcement about it. The announcements can be found here. What I usually do is that I will send out an email with the announcement. So if you don't check the Blackboard regularly, you will see the announcement in your email. Make sure my emails are not in your spam folder. And in the course content part, this is the part that that is the most important part of the class. Essentially, I will upload all of the recordings in these folders. So if you click on this right now, here you just see the syllabus, but later on you will see the recording of this lecture that we are talking about, and a recording of the other lecture, which will talk about the introduction to propulsion, not the introduction to class. And for each of these folders, which are essentially going to be, each folder is dedicated to one chapter, not one lecture. So we will have an intro to and syllabus, which is going to be your chapter 1 or 0, if you will. And then we will have the review chapter, which is the thermodynamics and all of the review that we're going to do for the class. And I will upload a recording and so on and so forth. And each of these folders will have a quiz in it. All of the quizzes are on the syllabus, which we'll get to. I have set a date for the quizzes. You will have a total of 7 quizzes. 6 of those will count toward your final grade, which essentially means that you are going to have a lot more quizzes. But most of those quizzes are not graded. They will just count towards your attendance. Okay? But 7 of those quizzes, which are already announced on the syllabus, which we will get to in a bit, are going to be graded and are essentially going to be acting as your midterm exam. And yeah, the assignments are going to be posted here in the course contents, the quizzes, the homework, the whatever, and not the assignments, sorry, the quizzes. And you will also see another tab, which you don't right now, but you saw in the instructors mode of the Blackboard, in which we are going to post the homeworks, the exams, and everything else. Okay, so let's get to the syllabus. Hopefully, at this point, you have already checked the syllabus. You already know that this thermodynamics is a requirement for this course, We are planning to change this requirement of D or better to C or better, because you have to know a lot of thermodynamics, and we cannot review all of the things you have learned in your thermodynamics. So make sure you understand like what is a TS diagram, what is entropy, what is a PV diagram, all of those relationships, first law, second law. We will do a small review, but that's it. You have to catch up on yourself. So if you feel like you are not caught up on your thermodynamics, make sure to go back and do a little bit of a review. And I'm always there to help you, of course, if you had any questions. Okay. So a little bit about me. My name is Mustafa Mobli, as you all know by now. We have listed my email here, which you can always send an email to, and you can expect a response pretty soon. I'm very quick to respond to emails, but if you didn't receive a response immediately or within a couple of hours, give me up to 48 hours, right? If you didn't receive anything up to 48 hours, it means that I have missed your email for whatever reason. You can always send another email. This is my office phone as well. Here, that's 803-777-7053. You can always call that number, but because of this COVID situation, there are a lot of times that I'm not in my office. Like at the time of this recording, I'm not in my office. So it is better to contact me through email. What I'm working on is actually to direct this number to my cell number. So if you call this number, it will appear on my cell phone, but it hasn't happened yet. We have the office hours. Office hours will be on Mondays from 12 to 2 p.m. You can always show up. I will update this on the syllabus, but it will probably be Wednesdays instead of Mondays from 12 to 2 p.m. You can always just show up to my office, or I will be online through Teams and Microsoft Teams and Blackboard. I would rather to be online through Microsoft Teams because it's easier. So you can always like ping me there. We can talk over there as well. But something that you have to make sure that you follow is the university guidelines as far as the COVID goes. So you have to make sure that you wear a mask in my office and anywhere else on campus when you are inside a building. And you have to make sure when we are in the class, you have to make sure that you sit 6 feet apart from each other. These are very important guidelines, so we have to follow them. Okay, and you can always ask me any questions if you had any about the guidelines or anything. Your textbook is a book written by Dr. Saeed Faruqi called Aircraft Propulsion. It's a very good book. I like this book, but there is another resource that we could have used. They're essentially very similar. They talk about the similar topics, and this is the undergraduate book for propulsion. But here, these two books, the book by Peterson and Hill, and also the book by Sutton, these two are a little more advanced and are dedicated to graduate level propulsion. And the last book that is an optional textbook is essentially an equationless book that talks about the future of propulsion systems and energy sources in aviation. You can always check that book out. I will try to incorporate this book in the lectures, but we already have a jam-packed semester. We are going to talk about a lot of things. If we had any time, we will talk about a little bit of future of aviation, essentially as far as propulsion goes. Class meeting time is Mondays, Wednesdays, Fridays from 10:30 a.m. to 11:20 a.m. If your other classes are online, let me actually write this down in the PowerPoint. So just two things: make sure you wear a mask always, and also if your other class is online, if all other classes, I'm just writing this in case someone doesn't listen to this, doesn't watch the recording and wants to just go over the uploaded lectures. If your other classes online, we can always pack the 350 minutes together in one day instead of coming to campus on 3 days, because my other classes are online as well, and we can have one session essentially. Yeah, my other classes are online as well, and we can just come in on a Monday. I would rather Wednesday. On a Wednesday from, I don't know, like 10 to, it should be 150 minutes, right? So let's do 120 minutes, 150 minutes, actually 10 to 12:30. Okay, we have like some breathing room in between. Just once a week, get done with it, be done with it, and then get on with our lives. Okay. This is an option. This is what we can do. So please reach out to me. Please send me an email. Think of this. I will upload this quiz, but essentially this will be one of the questions in your quiz. This will count as an attendance check. Okay, let's go back to the syllabus. Okay, the topics we are going to cover in this class are the jet propulsion principles, the dynamics and thermodynamics of perfect gases, quasi-one-dimensional flow, thrust and efficiencies, jet engines, propellers, and a little bit about ramjets and scramjets, if we had the time. As subsonic inlets, we will inlets, outlets, everything, we will definitely talk about them. Supersonic inlets, if we had the time, and we will talk about the turbojets, turbofans, turboprops, and different types of combustors, afterburners. We will talk about axial flow compressor and turbines, rockets, flight performance, and we will talk about liquid and solid propellant engines. And eventually, if we have time, we will talk about non-chemical rocket propulsion, which means like ion thrusters, Hall thrusters. These are pretty cool concepts. If we get the time to talk about this, I have done a very small project on this myself, and I'm a little bit familiar. So these are pretty cool thrusters, if you will. Okay. You can always study the course outcomes. I'm not going to go over them, but essentially these are our expectations from you guys coming out of this course, and you will be tested on all of these course outcomes. So you will definitely get a question that will test the first course outcome, second course outcome, or third course outcome on a final exam, on a homework, or on one of the quizzes. Okay, so let's talk about the lecture schedule. We have the introduction to class, and the first we will cover the first chapter of the book essentially today. First chapter of the book is pretty easy. It's essentially just an introduction to some concepts, and we will go over it. Some of the concepts may be confusing to you. You may not know a lot of things that I'm going to talk about, but that's all right. This is just an introduction. I just want you to see what you are going to see later in the course. So don't worry if you don't get it essentially. And for the second week of the class, we will have the review, and from the third week, or second and a half week essentially, from the fifth session, we will start the meat of the class essentially. But for the review part and chapter 1 part, you will get a homework, and for the rest of it, you will for most of the class, for most of the chapters, you will get a quiz and the homework. So we will have a total of 7 quizzes. As you can see, quizzes are listed here, and quiz times are listed here. Also homework times and their due dates are listed here. You will have a total of 6 homeworks and 7 quizzes. One of the quizzes will be dropped. Your lowest grade essentially will be dropped. Let me write these. I'm not sure if these are in your syllabus. Okay. Yeah. So we will. You're gonna get 30% for each quiz, but we have for all of the quizzes 5% for each quiz. Your lowest grade quiz, will be dropped. But the same doesn't happen to homework. So participation is also for the people who have already had a class with me. They know that participation is very important to me. So I want you guys to be engaged in class. If you're not gonna come to the face-to-face classes, you have to be talking to me through email, through Microsoft Teams or whatever. All right. The point is, I want you to be engaged in class and ask your questions. It can be a very simple question. It can be a question about the class schedule, about when the exam is, but I want you to be engaged and to be talkative, essentially. Attendance is also important to me. And your attendance will be checked through quizzes. Each quiz, we are going to have like 14 total quizzes, attendance check quizzes. And each quiz will have the same grade. Now we are supposed to make sure you drop the class or you fail a class if you miss more than 15% of classes, but I usually don't do it unless I see a student is like missing 50% of the classes, not 15. And you will have a final exam, and that's gonna be it. So keep in mind that all exams and quizzes are online. This is a university regulation as far as they have told me. So if you have a class section that doesn't follow on this, they don't know the rule, essentially. So this is what the university has asked us to do, which essentially means that all of your quizzes, quizzes will be uploaded online, but if you come to the face-to-face classes, they will be, we can do it on Fridays, or we can solve some examples on Friday. I have the quizzes online. What else did you want to talk about? So yeah, the quizzes are going to be online. The exams are going to be online. Your exams as quizzes are going to be open book, notes, and that's it. So I want you not to use internet. You should be able to answer all your all of the questions using your books and notes. And there is no way for me. There is a way for me to check this to make sure that you are not using internet, but I'm not gonna do it. We're just gonna be on an honor system. So make sure to. I'm gonna essentially trust you guys. I'm pretty sure you will follow on my trust. I hope we were in class so I could have answered your questions. But if you have any questions, make sure to, for people who have already had a class with me, they know that I really encourage sending an email, just asking your questions. Whatever question you have, no question is a dumb question. Every question is a perfect perfectly reasonable, good question. If you want something to happen in the class, if you have a feedback or comment about the class, make sure you tell me that so we can work on it. The goal of this class or any class is essentially for you guys to learn, right? So we want to create the best environment for you guys to learn whatever you need to learn. Okay. So my expectations from you is to show up to class or watch the lectures online on time. So if I post a chapter 1 lecture, don't watch it before a quiz. Watch it on a Friday or during the weekend on time, essentially. Make sure you submit your work in a timely manner. I'm usually pretty relaxed with the deadline, but if I feel like that you are abusing my relaxedness, if you will, then I will change the policy a little bit. Make sure you ask any questions, send me an email. I would rather if you guys don't come to my office, but if you feel like meeting face-to-face works better for you, that's all right. I will be in my office during the office hours, or we can make an appointment. And we can always meet anywhere else on campus, and just make sure you're wearing your mask and you're following the protocols. Be engaged in the class and come to class prepared. By coming to class prepared, I don't mean that you must like read study whatever we are going to cover in that specific class, but I want you to know and to understand what we have already discussed, right? To know what we have already discussed, to learn them. And if you don't understand anything, come to me before the class and make sure you understand it before going to a new discussion, essentially. Okay, and this part of the class, I want to get to know you better, and I want your classmates to get to know you better. But we have to do this on Monday. There's no other way around it. We will dedicate like 10 minutes or more or less to this. It doesn't really matter how much time. I want you to tell me what is your major, what year are you in, and so on and so forth. What are your expectations from this class and the instructor of the class? What do you want to learn? What do you think you are going to learn out of this course, essentially? We will talk about this. You will see the discussion on this in a little bit. In a separate lecture, they will be uploaded simultaneously, but it will be in a separate lecture. It will be a very simple discussion. Essentially, the only math part is the Humphreys versus Barton cycle. I'm pretty sure you guys have learned about cycles in your thermodynamics, like Brighton, Rankine, and the simplest one is the Carnot cycle. But if you haven't learned about those, that's all right, but you have to let me know, because we are going to use especially the Brighton cycle a lot, right? It is like the cornerstone of propulsion, the Brighton cycles and the Humphrey cycle, most of them. So if you don't understand cycles, then we have a little bit of problem. So make sure to bring it up in class on Monday, or send me an email and let me know that you haven't gone over cycles in your thermodynamics. Okay, it's a very simple math. The only reason I'm just separating these two parts is that to have the policy introduction lecture in a separate lecture. So let's talk about it. Let's talk a little bit about this roadmap. This roadmap is actually in your book as well. You can always refer to your book for this roadmap as well. So the focus of the class is the main part of the class is going to be chapter 1 through 5. The first part of the class, sorry. The first part is going to be chapter 1 through 5, in which you are going to understand and learn the basics of propulsion, the math behind the propulsion, essentially. Chapter 1 and 2 are just completely reviews and introductions. So these things are the things that you should know from before. If you don't, we are going to go over them again, but we are not going to spend that much time on them. if you feel like you don't know some things out of this review, that is alright, but you should come to me outside of the class and we will try to have a more comprehensive review on an individual basis. Okay. Chapter 3, we will talk about the engine thrust and performance parameters. Chapter 4, we will talk about the gas turbines and a little bit more detailed cycle analysis. Chapter 5 is essentially an introduction to UAVs and their propulsion system. Is very light on mathematics. It's just more of an introductory chapter. It's a very small chapter. It shouldn't take more than one lecture to cover. And then chapter 6, 7, 8, and 9, and 10 are essentially the chapters that are going to cover different parts of a gas turbine, of a propulsion system. And all of them are going to feed into chapter 11, which is essentially going to be a design chapter, a propulsion, fluid mechanics design chapter, in which you're going to be able to get an overview of a propulsion system, how to design a propulsion system, and how these different parts talk to each other, essentially, and how they all come to each other as like a piece of puzzle, different pieces of puzzle. And then the last chapter, which we are going to cover if we had the time, is going to be chemical rockets, which is mostly used solid, and we will have a small discussion on solid fuel rockets if we have the time, which is mostly used for space travel, and we will talk a little bit about hypersonic propulsion. But this part I have included on the syllabus, but I think it's a little too ambitious. What's going to happen is I will definitely prepare slides on this. I will definitely record a video, but if we couldn't get to it in the regular class time, this won't be a part of any exam or any quiz. Okay, but hopefully we will be able to get to it. So I think we spent a lot of time on policy. I think we have covered everything. Make sure you guys stay safe. And I guess I will see you guys on Monday. And yeah, I guess that's it. That's it for the policy. Make sure to ask any questions if you had any. Make sure to send me an email, talk to me, yeah, make sure we are always talking to each other because of this situation, because of this COVID situation. I understand that you guys, your ability, some of you guys' ability to learn is, how should I put this? Some of you guys learn better in a face-to-face setup, and because of this situation, some of you guys cannot take advantage of those kind of setups. So I will try to help you guys. I will try to be with you guys and be with you guys even more than before. So I just want you to make sure to ask your questions and talk to me. Okay, I guess that's it for today. That's it for this policy and syllabus lecture. I will see you guys on Monday.